Homework 11, Gathering and Organizing Data, Video 3. In the previous video, we saw how to build a frequency distribution for qualitative data. And in a word, it boiled down to counting. When you create a frequency distribution for quantitative data, it kind of boils down to counting also, except there's a problem. When your data is qualitative, meaning non-numerical, there's probably not that many categories. In the previous example, there were 4 categories: freshman, sophomore, junior, senior. Granted, there could be more categories depending on what the question was asked. For example, if the question was, what state were you born in, assuming that you were born in the United States, we could get up to 50 different replies. But when you have numerical data, depending upon the precision with which it's measured, these are measured precise to 1 decimal place, there's a chance that none of your values will match. In this example, 20 people had their height measured in inches to the nearest tenth of an inch. And here are their measurements: 70.3 inches, 74.5, 70.0. But because we're measuring these to 1 decimal place, it's unlikely that any of these are going to be the same. Here's a couple that match. There might be some more that I accidentally put in there. Here's a couple. But for the most part, there's a lot of different answers. And if we had more precision, chances are we would have 20 different values. So we can't do the same thing we did with qualitative data and just write every different answer here, because chances are all of their frequencies would be 1. So how do we overcome that when we're making a frequency distribution for quantitative data? The answer is, instead of counting each value individually, we create what are called classes. A class is just a range of values from this to that, from this to that, and see how many people fall within that range. Now, if you're going to filter quantitative data into classes, you don't just randomly come up with ranges of values. There are some guidelines that will help you build these classes. A little bit of terminology though. Actually, I'll introduce the terminology as we build our classes. The easiest way to build classes is to know how many of them you want in advance. Let's build 5 classes. So we're going to have 5 ranges of values, and then we'll just count how many heights fall inside of each range of values. But how do you build 5 classes such that they're big enough to capture all of these, but not so big that they go too far? For example, we wouldn't want to say something like 65 through 65.9, 66 through 66.9, 70, next number would be 67 through 67.9. I mean, we could do that, but those classes are pretty narrow, and there's a chance that some of them would be empty. We don't want them too wide either. For example, we don't want to say 65 through 69.9, 70 through 74.9, because then we would only need 2 classes. Half of you would be under 70 inches, half of you would be over 70 inches. So if you know how many classes you want, that's a good start, because then you can figure out how wide to make each one of them. So I want to give you some guidelines for building classes based on the data set and how many classes that you want. The first thing you have to do is calculate what is called class width. And the reasoning behind this is actually pretty intuitive. If I were to put all these on a number line, put dots on a number line, one of them would be the least and one of them would be the greatest. So imagine, we can imagine that. We don't have to imagine, we can draw it. If I do a number line and found the least value on here, which I believe is 65.0, yes. So 65.0 is here. And then the greatest value is 74.5, I believe. Yes. What we're basically saying is we need enough classes to cover all this, but we want 5 of them. So how can we figure out how wide each one is? We'll figure out how far apart these are and divide it by 5. So for the class width, what you can do is you can calculate the highest minus the lowest and divide that by the number of classes. I realize I'm running into my territory over here, so that will get erased momentarily. So let's figure out what the class width is going to be on this one. And then I'll tell you how to use the class width. Our highest value is 74.5. Our lowest value is 65.0. And since we want 5 classes, we're going to divide that difference by 5. So it does require a little bit of calculator. Well, you could probably do that without a calculator, but that's not really going to do anything except take more time. All right, so when we do that, we get exactly 1.9. However, we're going to use a rule about class width. We always want it to be a whole number. Now that's 1.9, so you probably think, well, we're going to round it up. And you would be correct. However, it's worth mentioning that you always round class width up. It does not matter what the decimal is. Even if it were 1.1, I would round it up to 2. The reason you want to round it up is pretty simple. If you round it down, they're not going to be wide enough to cover all the way across. So always round class width up. So that means when we build these classes, we're going to use a class width of 2. More specifically 2.0, because everything is rounded to one decimal place. In fact, the rule of thumb is you always round up to the however many decimal places we have here. So 1.9 would round up to, forget what I just said. Always round it to the nearest whole number. No. Always round it up to the next whole number. If you round it down, they won't be wide enough to cover all the way across. So we're going to use a class width of 2, and I don't really even need to write 2.0. We're going to use a class width of 2 because 1.9 would round up to 2. Again, even if this were 1.1 or 1.01 or 1.0001, it would still round up. Very rarely your class width will come up to be a whole number. If that happens, just go with it. All right, so first you calculate your class width by subtracting the highest minus the lowest and divided by the number of classes. Then you list what are called your lower limits. Each of your classes is going to start with a value. The first class should be the lowest value in the data set. Excuse me, the first lower limit should equal the least value. So our lowest value is 65, which means our first class is going to start with 65.0 and go through a certain amount. Now we'll close that class in a minute, but first let's build our 5 classes lower limits. The way you build the lower limits is you add the class width. First lower limit is the least value, add the class width to get the other lower limits. So in other words, here's how you use the class width, the 2 that we just came up with. You're going to add 2 to this lower limit to get the next lower limit. 65.0 plus 2 is 67.0. And then add 2 again, 69.0. And then add 2 again, 71.0. And then add 2 one more time, 73.0. And that's my 5 classes beginnings, open lower limits, if you will. Again, the way you progress from one lower limit to the next is you add the class width that you calculated in the first step. Now, we also have to come up with what are called upper limits. In other words, where each class ends. Now here's where, I don't want to say be careful, but don't close this one off at 67.0. That's where this one begins. If we did close it off at 67.0, then which class would somebody belong to if their height was 67.0? Would it belong to this one or the next one? It can't belong to both. The way you make the upper limits is you take the next lower limit and take it back 1 in the last decimal place. For example, the second class begins at 67.0. So imagine winding an odometer backwards 1 in the last decimal place. So if I take this backwards 1 in the decimal place, I would get 66.9. Because we're only measuring to 1 decimal place, the highest value that could be here is 66.9. Once it crosses over into 67.0, it's over here. And then you do the same thing with the rest of them. To figure out where the second class ends, you take the lower limit of the third class and dial it back 1 in the last decimal place. In other words, subtract 0.1 and you get 68.9. And you do the same with the rest of them. Dial 71.0 back 1, you get 71.9. Dial 73.0 back 1 in the last decimal place, you get 72.9. Uh-oh, we don't have another lower limit to dial back 1 in the last decimal place. Fear not though, look at the pattern in the upper limits. 66.9, 68.9, this is not correct, this should be 70.9. 72.9. Because the pattern in the upper limits, it's progressing by the class width also. In other words, if you add 2 to one upper limit, you get the next upper limit. So if we add 2 again, we get 74.9. We have 5 classes. They are all the same width. It's funny because the class width kind of describes how wide the class is, but the way you use the class width is to move from one lower limit to the next and from one upper limit to the next. Here's the mistake some of you are going to make. This is not how you use the class width. You don't say, this starts at 65, let me add 2 and end this at 67. No. The class width does not tell you how to build a whole class. It tells you how to go from one lower limit to the next, or one upper limit to the next. Well, once you've built your classes, this is just like the qualitative frequency distribution. We just have to do some counting. So now we need to figure out how many of these fall into each class. So I'm going to start with tally marks and then I'll change them into numbers. So starting with 70.3. 70.3 falls in the third class. 74.5 falls in the fifth class. 70.0 falls in the third class. 65.7 falls in the first class. I invite you to pause the video and see if you can go ahead and complete the frequency distribution. I'm going to go ahead and go through each one, writing the tally marks where they belong. We're on the second row. 69.0 belongs to the third class. So does 69.8. 68.1 belongs to the second class. 71.4 belongs to the fourth class. Third row. 70.3 belongs to the third class. 67.7 belongs to the second class. The next 67.7 also belongs to the second class. 65.6 belongs to the first class. Fourth row. 70.8 belongs to the third class. 72.0 belongs to the fourth class. 73.1 belongs to the fifth class. 65.0 belongs to the first class. Last row. 65.2 belongs to the first class. 70.5 belongs to the fourth class. 71.8 also belongs to the fourth class. 73.4 belongs to the fifth class. There should be 20 up here. I'm going to replace these tally marks with their frequencies. So the frequency of the first class is 4. The frequency of the second class is 3. The frequency of the third class is 6. The frequency of the fourth class is 4. And the frequency of the fifth class is 3. I had forgotten, but I remembered that all the frequencies have to add up to 20 because we still talked to 20 people. You know, getting a little crowded here. Again, this is just like a qualitative frequency distribution from this point. The relative frequency, you divide the frequency by the number of data points. There were 20 people, So for each of these relative frequencies, we'll just divide the frequency by 20. 4 divided by 20 is exactly 0.2. Well, 20 because we're going to make a percent. 3 divided by 20 is 0.15. 6 divided by 20, my apologies, I should have made these rows deeper. 6 divided by 20 is exactly 0.30. 4 divided by 20 is exactly 0.20. And 3 divided by 20 is exactly 0.15. So the corresponding percentages would be 20%, 15%, 30%, 20%, and 15%. When you run across these two questions in your homework and you only have two like this, stay very focused when you're building the classes. That is the hardest part of this. The rest is just counting a little bit of division and percent, converting decimals to percent. So just to summarize, if you want to know how wide to make each class, subtract the highest minus the lowest and divide it by the number of classes you want. You will be told how many classes to build. Round that up, no matter what the decimal is, round it up. Grab the lowest value to begin the first class. Add the class width to that to begin subsequent classes. And then to close off each class, just take one class's lower limit and take it backwards one in the last decimal place. And then you can do that again, or you can just add the class width over and over. Ooh, that was a long video.